So I guess a bit of this is my story, and I'm sharing with you. I work in developer relations. I work on Atlassian's DevOps ecosystem. I was glad to participate in the recent release of AWS's CodeStar integration with Jira. So those, AWS, Azure, I've worked with some of the other vendors, Puppet, Splunk, to help make sure that these integrations exist. I don't do all of the coding, but I get to see a whole lot of integrations, especially in the DevOps space. But my story about DevOps actually goes back for many years. For me, it's been the kind of what's next after Agile. So I've been very passionate about it for some time. And one thing I've noticed about this space is that there's this sort of to do is to be. You have to have a certain integrity in this space. So some of the advice that I'll be providing in this deck is about how to embrace DevOps for yourself so that you can bring it to our customers. But that's not the title of the presentation. So while I have advice that applies to you, I also have a view on the market. And when I look out at the software industry itself, I can't help but see DevOps as a major business opportunity. And that's because I see a huge problem in almost every IT organization. The DevOps handbook brings us this gem. In almost every IT organization, there's an inherent conflict between development and IT operations. So the handbook continues, resulting in ever slower time to market for new products and features, reduced quality, increased outages, and worst of all, an ever-increasing amount of technical debt. And the handbook goes on to describe how this system emerges in 3 acts. Act 1 opens on IT operations where applications and infrastructure are increasingly like they're poorly documented, they're incredibly fragile, they're increasingly complex. And as the handbook points out, alarmingly, our most fragile artifacts support either our most important revenue-generating systems or our most critical projects. So hands up if this is what you've seen in some of the customers that you've worked with. Yeah, it's a sad fact. That the stuff that's most important is the hardest to deal with. And because businesses need to change to keep up with business market needs, these critical systems are also the most urgent focus for change. This is a fundamental rock in a hard place, right? We need critical systems to be stable, but we also need critical systems to be changing rapidly. Act 2 begins with competing for broken promise or compensating for broken promises with even more promises. So somewhere in the organization, management, product managers, maybe even the dev teams themselves start to make promises or commitments to bigger features, better performance, a larger revenue target, whatever it is. Now comes development's contribution to the problem. The only way to even come close to these escalating promises is to take more risks, it's to cut more corners, and it's to increase the technical debt. And inside the development teams, these are good-hearted people. They have the best intent in mind, so they tell each other, we'll fix these problems once this release buys us a little bit more time. And hence this all promise outruns performance. Because in the 3rd and final act, everything just becomes a little bit more difficult bit by bit. The technology has become more fragile as more technical debt is rolled out, and the impact of failure seems to grow even more intense. It takes longer to get the next release out the door, and more bugs fill up the backlog, and so we see this ever-escalating downward spiral. But it's not just like the technology systems that are suffering this way. The people are also changed. Communication gets a little bit slower because everyone has gotten busier. Fear creeps in, causing every individual to check and double-check with whoever they perceive are the experts. Collaboration is soured by escalating blame between development and operations. And people start to keep observations to themselves, lest they face the blame or they point the finger somewhere else. So at the Agile conference in 2008, Andrew Clay Schaefer proposed a birds of a feather session, and the topic was Agile infrastructure. So only one person showed up. It wasn't even Andrew. So the comments on the suggested topic were so dismissive that Andrew just didn't think anybody would, but Patrick Dubois showed up. Later, when the two connected online, they started DevOps Days and eventually dropped the word days for a shorter Twitter tag. And here we have DevOps. So intellectually, DevOps is the child of Agile. Just as Agile has helped software development teams to embrace changing requirements, DevOps is about embracing change in IT operations. So why does this cultural movement need a new name? I think it represents this, just how profound it is to get dev and IT operations to work together. And the nearest analog in the Agile space is when you get dev and test to work together. So I don't know how many of you have been in part of Agile transformations, but that's a pretty profound thing. The end result of that kind of collaboration isn't just test automation, that's a kind of simplistic view, but it's actually that testers start to participate in a more meaningful way. You get better specifications out of earlier participation, and you get smarter testing. It's not just all of the stuff that people did before manually converted to automation. It's really smarter and better. So getting dev and ops to work together is more than just restructuring the team, like putting dev and test together. It usually takes broader organizational change. The tools and practices for that are still emerging, but DevOps is the cultural movement to discover and share that path to organizational change. So our contribution to this is represented in a game plan that we have provided alongside the health checks and playbooks that we have that link these the kind of view into DevOps, into what are the right health monitors to run for a team, and which plays matter most. So our first step to this was released maybe a matter of weeks ago. You'll see this emerge over the next year, where it will be elaborated from experience. Hopefully, folks like you will give us some inspiration and help contribute. But even if DevOps came from Agile thinking, that doesn't mean it was born fully formed. There are current industry forces that are shaping DevOps and help explain why it matters to businesses. One of those is this idea that Forrester coined, was the idea of water-scrum-fall. And in many organizations where Agile has been a success, it took root in the software development team. But it has done great things to help overcome the bottleneck that often is software development. So, but after a year or two, Scrum and Agile technical practices help elevate the constraint from development. And what you're left with is that on the business side, you have large annual planning cycles, often very much budget-driven, and on the operations side, you're still left with big bang releases, heavy change management or release management practices, and so the constraint in this system shifts. Now, theoretically, it could shift towards where the annual planning side is. I think a lot of organizations struggle with a truly agile planning approach, but the blame usually ends up in the operations side. And so I think this is why DevOps is really much more about the interaction between developers and operations. But this becomes an important forcing function, that Agile is starting to drive the need for change inside of the IT operations side. So another force driving the need for DevOps is the cloud, especially infrastructure as a service. So increasingly, IT operations is being forced to move from competency in infrastructure, which is increasingly becoming a commodity, towards a competency in the domain of the business. And that's a real shift for IT operations. Today's sysadmins can't just monitor CPU utilization and disk space. They have to monitor business transactions and overall cost of what they're running. In addition, there are like virtualized computing has made it easier to do a lift and shift into the cloud, but still leave some unanswered questions about what it is that they're supposed to be paying attention to. So they often need a much different skill set than bare metal infrastructure, And DevOps addresses the cultural fallout from this kind of technology change. And then digital transformation. And I think this is best summed up as, this software is eating the world idea. It's a pretty big thought. But it means more and more companies are finding the software that they build is a core competency of how they drive their own business. So a couple years ago, Diogo Lucas gave a summit talk about how AGCO, a company that builds agricultural equipment like tractors, is now deriving competitive benefit from software. Basically, their tractor software uses geolocation and other sensors to correlate crop yields to location, so farmers can adjust how they treat different parts of their plots, optimizing their overall yield. So in this new model, even very much hardware-driven companies can create value by collecting data, transforming it to customer-valued information, and then doing that faster and cheaper with each iteration. And again, DevOps is foundational for building this kind of learning system. So if those industry forces shape the needs that our mutual customers have, DevOps is also changing the way that customers consume products and services. So the first time I heard about non-functional characteristics or non-functional requirements, I actually laughed out loud. I thought to myself, why would you bother specifying something that a system wouldn't work? But that's not what non-functional means exactly. It's not about the parts that don't work. It's about these subtle characteristics that we sometimes call illities, like reliability, supportability, or usability. But I think there are 4 specific characteristics that have become front of mind in this DevOps and cloud age. And they're here. So reliability is often measured in terms of mean time to recovery. As an example, TCP/IP was designed to be highly reliable because when parts of the network fail, the system will self-heal and route traffic around broken parts. This happens so quickly and automatically that it makes the internet as a whole feel highly reliable, even as parts of it are coming offline or going offline on a regular basis. Performance has become one of the primary concerns for usability on the web, to the extent that New Relic has made a business around summarizing your application performance with a single number called AppDex, or how profound it is that Amazon can calculate the impact of 1 second slower page load times, and they calculated that would cost them $1.6 billion a year. So there's a real business impact of performance. And last year was so full of internet security news stories, everything from Yahoo data breach to Hillary's emails. I'm sure everyone here wants to avoid that kind of negative press. And yet we don't see enough people planning to be secure. So this goes hand in hand with reliability in that being able to recover quickly from failure also supports the ability to be able to respond quickly to malicious actors. And scale has increased so much that we now invent new phrases like web scale to talk about how applications have to service so many people. So even for on-premise applications, the expectations that it will work for tens or hundreds of thousands of people are quite common. So I think it's that DevOps has so much to say about how to bring these to an organization or how to bring these to a software product that it's changing expectations. So even as organizations struggle with their own IT operations concerns, they start to see non-functional requirements in a new light. So they may be working on how to figure that out and bring these to their own products, but they're now looking for it in the services that they consume. And there's another kind of change. DevOps changes who has authority to buy products and services. So in many ways, DevOps is a democratizing force. It brings a lot more people into the software buying decision. And then there's a lot less command and control and more delegated authority, or another word for that would be autonomy. So more activities become collaborative and team-oriented, and so more users need access to pretty much everything. As continuous experimentation and learning kick in, there's a faster pace of change, which is why the people need to actually change the workflows that they're using, perhaps in Jira or around different kinds of tool sets that they have. And to capitalize on innovation and creativity, there is more team-to-team variation and do-it-yourself customization or automation. Hopefully, you guys are all seeing some opportunity in those kinds of changes in an organization. And to elaborate how DevOps changes interactions between people and tools, I think it's not surprising to say that humans and robots have to work together in the transition. Right? We kind of all have this idea that, well, if they're doing everything manually and then we have to get to automation, yeah, there's going to be some kind of interaction between manual and robotic work. But somebody, so more than just somebody has to build the automation in the first place, I actually think that a good organization is going to find an interesting mix of interaction between humans and robots. So in real-life DevOps automation is often surprising about where that automation ends up, but it relies on the fact that humans have certain skill sets and robots have a different kind of skill set, and you want to find the best way to bring these two things together. So robots excel, or humans excel when there's high variation, there's a need for innovation or a need for creativity, while robots, on the other hand, are really good at dealing with the highly repetitive, low variation, where there's complex calculations. Those are the things that they do well. And so in highly skilled DevOps organizations, you often see people and robots working together all the time. So there's 3 ways in DevOps that are important to take into account. I think a lot of people get a little bit carried away on this first way as the only way, which is improving the flow from dev to ops. The real thought behind it is systems thinking and understanding the flow from dev to ops as a workflow, as something that you can tweak and optimize. So there are practices like automated testing and continuous delivery that help remove surprises in that flow. And so, even though automation can play an important role in standardizing the work and helping make that flow more easily, it's not just about automation. An important aspect is amplification of feedback. That is, making sure that ops has a signal that they can send back to development about what's going on. So that's represented with this loop back the other way. A thought in the DevOps world is this idea devs wear pagers. Of course, I don't know that anybody has pagers anymore, but the thought is that devs have a responsibility to respond just as much as operations do. That's often the most disputed part about DevOps from the dev perspective. But practices or tools like log management are often the kinds of things that fit in there. The third way adds these tiny loops indicating continual experimentation and learning. On my team, we just simply call it small wins. It's the idea that you just build small pieces, you get them out into the world and learn from what happens there. So another aspect is that making sure that these changes are isolated enough that you understand what the impact of each change is, and that you're making them safely and frequently. So Atlassian tries to help folks visualize that kind of continuous learning by mapping what they often know today into this continuous loop. So here we still have ideas like plan, build, continuous integration, deploy, operate, and continuous feedback. But I think over time that, this becomes even more, as this gets faster and faster, the idea of planning and building and deploying and operating as really separate steps really starts to disappear. Around it all is the piece that Atlassian likes, I think, to focus on most is the idea of collaboration. It's the thing that makes us most different in messaging around DevOps. Okay, so if I've gotten this far to just try to bring you up to speed about how we're thinking about DevOps or what I've seen out there in the market, let's put the theory aside. I did say that I would help you understand a business opportunity. So what are we going to do to help separate customers from their hard-earned money? Well, let's understand the opportunities there. So first is, if we come back to those ways of thinking, the first way is about systems thinking. And unfortunately, the way that I think most people understand this is that you just stretch continuous integration into continuous delivery, and that's what brings you the flow from dev to ops. But such a focus on automation only often leaves people not understanding that there's some subtle aspects to this. But let's take this as a pattern that there's an idea called push-button deployment. So that it has some kind of immediate appeal. Most developers want it to be easy to deploy. Most operations want the same thing. Management can even appreciate this. But if we look at the opportunities behind this, I think there's a couple things. One is that there's a cultural change that has to happen around this. And that presents an opportunity for some services. So even as you're bringing in tools from Atlassian or tools that you're building as integrations or add-ons, there are some service opportunities here. That's because it goes beyond how automation saves time or effort over manual tasks. That's great. But when we talk about systems thinking, then we need to look deeper at these cultural aspects. So one is encoding knowledge. And the idea that you're putting the know-how to do these steps into an automated system means that you really can't lose the fact that people have to understand what the automation is doing. So often this means visualizing workflows or making sure that the code is available to anybody on the team and not just a subset of experts. The second thing is that sharing the capability. So it really matters where the push button appears. It's great that a tool like Bamboo or hopefully not Jenkins, but that those things do provide a push button capability, but to have, that doesn't make it open to everyone to be able to push that button. People still feel like they're going into a very technical tool if they have to go into the CI build tool. So sharing that capability by putting it into a HipChat channel or into the right Jira workflow step so that more and more people eventually, I think what people find is that they want to make deployment or especially the idea of release, make that into a business decision. And that means pushing this push button deploy idea more and more up towards the business. And then the third thing here is encouraging release. So push-button deployment may mean you have the capability to do this quite easily, but for cultural reasons, it may get more and more difficult. The easier you make it, the more you start to run into barriers like testers or operations who become afraid of the change. And so we have to face this idea that we want to encourage release. Now, push-button deploy can make that easier, but I think there are other cultural aspects. You have to build in some trust there and make sure that the testers understand, hey, automated tests are running every time, or that operations understands that the configuration changes necessary to get this out into production are baked into that push button. So then we come to some of the product ideas that push-button deployments opens up. Some examples from things that I've worked with include deploying to Azure from Bitbucket. So that's kind of unusual because it's not in the CI tool itself where you kick that off. It's in the version control side. Another one is the example of Hubot for HipChat, which can initiate all kinds of automation. The idea there is that there's a kind of shared command line for the team so that the magic of how to issue the right command is visible to everyone. That gives a chance to for everyone to learn what the command is and execute it on their own. And then another thing that happens in time is that the idea of deployment may separate from the idea of release. That is, for somebody like Etsy, when they deploy tens or hundreds of times a day, that doesn't mean every deployment has a new feature in it. Oftentimes, those features wait until there's some interesting market event. I noticed that at the AWS Summit that they were able to pull a feature flag off of AWS CodeStar and announce it right on that day. You don't want to carry all of the risk of putting some new code into deployment just to get a new feature. And so the way that this is often manifest is by feature flags, or feature toggle, same kind of thing. And there are many products in this space. that do this. So working with Split was one way where we have integrated Split and Jira. So while the patterns are well established for this, that hardly means that the market is saturated. So first, there are lots of places to put that push button. It's not a one-size-fits-all. For in some organizations, the right place is Bitbucket because it's the source of something releasable. In other organizations, Jira is the right place to put that button because it's where the business will see all of the work in a release. And in other organizations, maybe it's Confluence, or even, as I've given an example here, a physical button like the AWS IoT button. So there's still lots of opportunities for that, getting the button in the right place. Another important aspect is separating the act of putting the code into production, as I was just explaining about deployment versus release. While there are commercial products like Split that are focused on this, a lot of the tools that people are using are still open source. And so I think that provides a lot of opportunity to integrate those tools into Jira. And for that matter, there are just as many tools for automating deployments, and again, many of them open source. So we don't necessarily need more, but we do need more ways to access those buttons or get them into the right place. So finding the way to really put the, connect to the triggers or the things that do all of the automation. And this gets kind of interesting because there are things like, well, which build plan is this for, or which set of code is this for, and helping customers or express that in the way that makes sense for them. All right, so if that's the opportunities for the first way, let's start talking about the opportunities for the second way. So if the second way is about amplifying feedback, we're talking about log management tools and this devs wear pagers idea. Then the pattern that I've seen quite often is create an issue. And it sounds so simple on the surface. Hey, you have an automated tool that raises some kind of exception or flag that developers are going to have to deal with. Sure, create an automated, or automate the idea of creating an issue there. But I think there's more to it than just this automation. There's real amplification of feedback going on here. And there are three advantages to this pattern, all of which, again, I think have these cultural impacts that open up opportunities for services. One is closing the loop. So it makes it easy to open a channel from ops to provide any kind of formal feedback to dev. And that means perhaps that in the create an issue cycle, it's not just an automated process, but it's sort of semi-automated, where ops can provide some additional context or information that they have from their own insights. The other thing that this does is that it communicates with context. So it's starting to bring information into the dev cycle that they might not be familiar with. We hope that developers have all seen the kinds of stack traces that might get thrown out in a production environment, but they may not know all of the kinds of errors that can happen in the real world. So getting some of that information back to devs may need to come with some education about how to deal with this in their own code. And then there's a really subtle idea here of tracking unplanned work. And it may seem kind of contradictory. Well, if it's unplanned, how would you put it in the backlog anyway? But I mean that you have a kind of record of when something unexpected has happened, we can see that and weigh it against the kind of planned work that we have in a sprint. And that means starting to put things like buffers into sprints and understanding that the farther away we are from now, the more we're going to learn in time, which means we better leave some room in our sprints for those kinds of learnings. So there are also some products that have implemented this quite nicely. Sauce Labs in the testing space provides their own test automation. But what they help bring back to Jira are test details, including screenshots and videos and logs of what happened in a browser or on a given mobile device. There's security concerns that can come back. So this is SourceClear is a tool that we use inside of Atlassian for keeping track of some of the security vulnerabilities in our downstream libraries. So we want to make sure that it's easy to bring that back into the sprint and plan for addressing those. And then there's even an interesting one here. This Cloud Manager add-on is able to bring back some, like raise a Jira issue if the costs get too high in production. That might be because dev has spun up a bunch of instances to help sort through their testing and their security concerns that they got from another issue. So there's all kinds of ways that these operation signals can get back into Jira. And again, while there's an established pattern, it's hardly a saturated market. So there are lots of sources that are yet untapped. Plenty of open source products that are able to provide these kinds of signals for which there are no, not necessarily integrations yet. For example, ElasticStack, Zabbix, and Nagios are some very popular monitoring tools that are free. So they're unlikely to build that themselves. Another aspect of create an issue is getting the issue in the right place. So there's lots of opportunity to do some smarter routing here, getting it into the right project or the right issue type or for the right person. And I think that's a place that I have talked to some folks that are kind of exploring those ideas, but I think is as yet untapped. And moreover, it's not just being smarter on the way in, but somewhat on the way out as well. So issues that have been creating with a monitoring context could use that to be even more effective to make sure that problems are really resolved. For example, imagine a tester having a picture of what went wrong in the first test pass, like literally an image. Not so much to verify that the regression was fixed, but to check that the fix actually makes sense overall. So not just, like, did we fix the red underline, but is this user experience really what the users want? So if that's the second way, now we come into the third way. We're talking about experimentation and continuous learning. And when we make these kind of faster changes, this is maybe where it's even more obvious that there are cultural changes. And some of those have to do with or services around instrumenting flow so that we can correlate events. This helps us build connections between different tools. A lot of times, especially when in a DevOps transformation, you're going to be bringing together folks from a dev world that have their own set of projects, or from the ops side that they have their own set of projects as well. Want to be able to start to connect those things together, not just to issues, but also then to code commits or to builds, deployments, and production events. Another is to find empirical insights. So we're really trying to take away the blame culture by helping provide more data for every kind of decision that we make. So empirical insights into not just how the systems are working, but how the people are working together. And then to be able to provide the necessary data and information that helps people improve with little tiny experiments. So those are definitely service opportunities. In terms of implementation, right now, really the only thing that I've seen so far is the Splunk app for Jira, which allows Splunk's big data and machine learning capabilities to be applied to analyze trends in Jira issues. I'm quite fond of two graphs that can come out of that, the cumulative flow diagram and statistical control chart. And to kind of provide a little bit of insight on how you would use some of that kind of data to make process improvements, we put those kinds of, like the steps that people might go through on a lead time ladder that's usually associated with lean value stream mapping. The problem is, if you don't have a discipline like this, is that people tend to focus on what they can see easily. So for example, we might have automated steps that are taking place for each of those. Many compilers and test tools will just kind of advertise how long they took for execution. And so that leads many folks to kind of focus on the longest running automated activities. In this case, maybe the kind of testing that occurs in staging. And you might get into focusing, how can we make this testing run faster? However, when you back up and include the wait times, which are the kind of handoffs between activities, you can really see that the cost in the overall cycle time is really in the handoffs. So, and guess what? This is really where typically you're going from different parts of the organization, like from dev to QA, from QA to ops. It's really hard to measure these wait times because org boundaries also mean tool boundaries. So that's where something like Splunk's measurement can come in to help you understand where these are when you have the correlation between different events. So once instrumented, we start to see that, yes, okay, we want to drive to automation, but where we apply that automation might be very different than when we paid attention to only the automated activities. So we start to focus on how do we automate the handoffs between groups, or what information has to be in there so that we can do a more automated handoff. And that means we're driving on a goal that is beyond the kind of like feeling better that happens in, I think, too many Agile retrospectives. And it's not just about what's good for the dev team. It's really about making sure that the overall flow gets better. So that brings us to the conclusion of the 3 ways, but I want to leave you all on a message about getting started. So first, I do suggest that you embrace DevOps for yourself. For example, if you're already in the Atlassian marketplace, make sure you aren't missing the opportunity to make non-functional characteristics a competitive differentiator. And second, I suggest applying lean startup thinking to DevOps. So namely, build something for the marketplace based on your hypothesis about what DevOps is doing. Don't forget to measure acquisition, adoption, retention, revenue, referrals, and then learn from that experience, adapt and change and grow. But getting started is easy. So, start now. I think the industry is crossing the chasm. I think you're going to see Atlassian putting a lot more wood behind the arrow for DevOps and increasing its DevOps messaging. So please take advantage, draft off of our marketing effort. And with that, I hope you'll get started, and I thank you.